All right, here we are back at the whiteboard. A little acid nomenclature. So there's a lot to this acid-base stuff. So let's look at how we name, how we write formulas for acids, specifically in organic acids. We typically don't do a lot of organic acids. By the way, I probably should show you. An organic acid would have a carboxyl, has a carboxyl group. Okay, so there's the carboxyl group there. And what makes this an acid is this, when this bumps into something, this acid can donate this hydrogen ion. So that can be donated to something. That's an organic, this would be an organic acid. Organic acid. Amino acids have this group. They also have an amine group. So we don't do a lot of that. We do a lot of acids like this. We call these inorganic acids. So you can tell for all four of these that I have here, they start with an H. So this isn't exact 100% correct, but acids typically donate hydrogen ions. And they can donate more than one hydrogen ion in some cases. All right. So let's look at these acids and see if we can figure out how to name them. So notice this acid has a polyatomic ion in it, just like this does. And this polyatomic ion, NO3 minus 1, so this is made up of nitrate and a hydrogen ion. So this is nitrate. Oh, sorry. Nitrate. Now, if the polyatomic ion ends in ATE, what we do is change this to ic. So 8 turns into ic. So we say nitric, and then we say acid. Nitric acid. Remember the See You Later lab where we added the nitric acid to the copper and the brown gas was given off, that nitrogen dioxide? This is the acid that we use in that case. So 8 to ic. If the polyatomic ion ends in ATE, change it to ic, say acid. How about this guy? So this is it's a hydrogen ion. That's nitrite. Nitrite is the name of that polyatomic ion. So you're going to have to get out that polyatomic ion sheet. And I think I used that for today's the recent assignment. So get that out. You'll need to use that when writing formulas for acids. So nitrite. So what we do with ite, we get rid of the ite and say us. So ite turns to us. So we say nitrous acid. Okay? Nitrous acid. Hope you can see that. So polyatomic ion ends in ATE. We change it to ic and say acid. If it's ITE, we change that to us and then say acid. So nitric and nitrous acid. So how about this guy? Do you recognize that C2O4 minus 2? And there's 2 hydrogen ions here. So this is called oxalate. So oxalate. The 8 turns into ic. This would be called oxalic acid. It is, oxalic acid. Can't think of. I know the oxalate ion, calcium oxalate makes up kidney stones, but I'm not sure where you come across that acid. Anyhow, that's a polyatomic ion. Recognize that. Now, how about this? So this ion is fluoride. Fluoride. So in this case, we have an ion that ends in IDE, a monoatomic ion, IDE. We want to say hydro. Now, instead of saying fluoride, we would get rid of the IDE and we would say ic and then say acid. We want to use a prefix hydro, the suffix ic, acid. So in this case, we got rid of the "ide" and changed it with an "ic." hydrofluoric acid. How about HCl, of course, would be hydrochloric acid. Okay? So hopefully that'll help. Organic acids have this carboxyl group right here. Carboxyl group, they can donate hydrogen ions. That's the hydrogen ion that gets donated. And then we have these inorganic acids. They're either made up of a monoatomic ion or a polyatomic ion. The polyatomic ion ends in ATE, change the ATE to ic, say acid. ITE, change it to us and say nitrous acid, say acid. If it's a binary acid like this, where it's just made up of a hydrogen ion and a monoatomic ion. And remember, these guys are going to be over here, inside the periodic table. Ends in IDE. We change the IDE to ic. We use a prefix hydro, hydrofluoric acid. This stuff is used to etch glass. And of course, hydrochloric acid is in our stomach. We use it a lot in chemistry. So, acid nomenclature. Hey, review this again if you need to, and I'll send you some practice. Bye.